Hi, welcome to this lecture. In this lecture, we will look at many-to-many relationships. So that's the objective. Learn to model many-to-many relationship involving two entities, and we will create a database based on two entities where we have many-to-many relationship between these two. After that, we will write some queries on this database, and we'll see how the life will change in case you have many-to-many relationship and you want to write queries for that. So before that, let's start with an example. Like, what could be a scenario, since you are creating your project and you are probably at the stage of creating your RDM. So now the issue is, how do we identify whether this is the case for one-to-one or one-to-many. We have already seen one-to-many or many-to-many relationship. So I will start with a very simple example that is related with university database. So let's pick two entities here. I am using conventional ER diagram notation where entities are represented using rectangles and relationships are represented using diamond. So let's see, we have an entity called student and the other entity is course. If you want, you can put students and courses. Then there will be a relationship between them. Let's make that using rectangle. Using a diamond. Diamond represents relationship, and I should give a name to this relationship. Let me call that registered in. So a specific student is registered in course, a specific course. So in order to understand the nature, right, so this many-to-many thing that we have, this is called multiplicity, which means that in this relationship which is registered in between students and courses entities, how many instances of student would be associated with one instance of course, and similarly for for how many instances of students are associated with one instance of course, and for one instance of student how many courses are associated. So to make it clear, let's take an example. So first I will take an example of student to courses. So it is very common that in a typical semester, let's say fall of 2020, it's possible that a student named Sam may take multiple courses. Let's take this 3 courses for the example to make the things easier to understand. This student called Sam may take these courses: CSE 101, just making up this example, CSE 114 and ISE 305. So that is a possibility. I don't know how practical it is, but that is possible. A student named Sam may register in these 3 courses in one semester, or might have taken these courses in his degree program. So a student may register in multiple courses. So this is from student to course, right? So one student to many courses, that is something established here. And at the same time, let's look at the case from course to student. So if we take an example of a course like ISE 305, okay, so ISE 305, which I have been teaching for a few semesters, it is very common for me to have more than 100 students, 120. Okay, if it is a regular semester, like in summer usually I get less students, but in the fall usually I get students around 120 or 120 plus. So one course may have multiple students. Okay, so ISE 305 will have multiple students, and if you look at the student and to the courses, then one student can also take multiple courses. So this is many to many kind of relationship. You will show that as M to N. M for many, N to many. Okay, so student can register in multiple courses, and one course will also have multiple students. It's very rare to have one student in a course, but that might be possible in some very strange cases. But in any normal circumstances, you will find multiple students registered in one course, and a student can also register for multiple courses. So this is a true example of many-to-many relationship. There are a number of cases where you'll find many-to-many relationships. Okay, so now the example that we have in this lecture is an interesting one, and as usual I shared the data set with you on Blackboard. So please go to the Blackboard and download the three data files. These are sales, items, and line items. So you will understand what this data is all about in the next few slides. So let's try to understand the domain from which we have this data set. Let's think about a sale. So we can keep the information about sale in a form like this. So what you're looking at in your screen is a sales form. So let's see like what items should be there in a typical sale. So for sale, you may have a sale number right here on the top. So each sale that you are doing would have its specific sale number. Sale number 1, 2, 3, so on and so forth. And the number right here is sale number 1, 2, 3, 4, 5, 6. That means a lot of sales have already happened. And each sale, you will have the item number. So if it so happened that in a particular sale 6 items were sold, then you can put the item number here. Okay, and items are coming from a different table. So we have a data file for item also, but this file that you're looking at, or this table that you're looking at, will store the information about a sale. So in one sale you will have the list of items which were sold. So here it seems to us that 6 items were sold, and we should find out the item ID. So in item table we should have item ID corresponding to every item. Then you can write the description, then you can say the quantity, like if it was an item like pen, okay, and this fellow bought 20 pens, so you will write 20 number of this item. So you have quantity, then you'll have unit price. You can compute the total quantity multiplied by unit price, so you'll get a total, and then finally you can get a grand total. So interesting thing here is that in this table that we will have only information about sales. Okay, so let's look at the other entity or the other data source. This other data source is about items right here. So a sale includes multiple items. That's what we had in the previous slide as well. And items with the same item number might be sold to many customers. Okay, this is about the many-to-many thing. But before that, let's look at this item table. So right here, you are looking at item table. So in the item, see, we have different items which are being sold at this store. You will have ID for items. So here we have just 4 items shown because of the space constraint. I think in the original item data file that you have, we have at least I believe some 10 items. So you have item number, then name of the item, followed by item type. So there is a type associated with every item, and then you have item color as well. Now in this sale that you have here, you need to put these values, item number here. Alright, so if the person has bought a pocket knife, so you should put 2 here. Alright, so like 3 and 4. So that means that in this sale these 3 items were bought, item number 2, 3 and 4. Okay, so this is an example of the relationship, you may say, between the sale and item. Okay, so now let's try to understand the nature of this relationship which will be present between item and sale. Now, the same item, right? You have a pocket knife, which is Avon brand. So it may be the case that this is very, very important, right? So if this is a very important item, then you should expect that a lot of people are coming to the store and they are buying this item. So the same item can appear in multiple sales, right? So if you're looking at this angle, like one instance of an item, in how many sales it can appear. So it's very practical that if we have an item which is very popular, then a lot of sales will happen for that item, and that item may exist in multiple sales. So there is one to many, kind of association from item to the sale. Now let's look at the sale. So how many items can we have in a particular instance of sale? So if you look at the sale, then in the sale I am buying 3 items. So from the sale point of view also, in one sale you can have multiple items. One item can be sold to multiple sales, and similarly one sale can have multiple items. So that means it is a perfect example of many to many relationship. This is between item and sales. So items with the same item number might be sold to many customers, and a sale includes multiple items, right? So this is established that the relationship which we will be having here between item and, I should write this, sale table or an entity is going to be many to many. Alright, so okay, now let's look at the data file that you have. So as I was saying, this is the file that you already have on the blackboard. Please download it and start doing the exercises. So here we have the field ID, then item number, item name, item type, and item color. So it seems to me that this thing that you're looking at is being added by MS Access. Probably this is a field that MS Access added for you as a primary key. But if you look at these values, then these values are just the same. If you want, you can ask MS Access to add this field, or otherwise you are anyway fine with item number, which is a primary key, which can be, I will call that as a natural primary key. Why natural? Because it was already there in the table. ID is something you have got from MS Access. MS Access asked you that should I add one field as a primary key for you. You can say yes or no, and if you say yes, then it will add an ID field for you. So that's about the item table or item data file, items data file rather. Now let's move on to sales. So what should we have in sales? So here again, seems to me that this ID field is from MS Access. Alright, sale number and ID, they are perfectly matching. So sale number would be your natural primary key. Other than these two fields, let's look at the remaining information. So you have a sale date that signifies when exactly this sale was made. So we have the data about 3 dates only in this slide. Some sales happened on 15th of Jan 2003, and there's one sale that happened on 16th of Jan 2003. Okay, then you have some description about the sale that describes the sale. Okay, fine. So now there's an interesting thing which is about modeling this relationship. So how do we implement, and before implementation actually we should think about modeling. So this modeling is little tricky, and it is different from one-to-many relationship. This is slightly more complicated than one-to-many relationship. So we need another entity in between the two original entities like items and sales. In order to model and implement this many-to-many relationship, you will need another entity that you see right here, line items, and this is called associative entity. Alright, and what does this entity do? This entity, for the sake of implementation of many-to-many relationship, establishes a one-to-many and one-to-many relationship. So one-to-many, when it is implemented by the associative entity or the table, you get many-to-many thing. Okay, so that's how many-to-many relationship is established. It cannot be done the way we did from one-to-many. Alright, so that's the point here. For many-to-many relationship, it cannot be represented directly in the relational database. So what does that mean? The way we did it in case of one-to-many relationship, if you remember, we did not introduce any additional associative entity or additional table for that relationship. What we did, we added one foreign key field in the many part of the one-to-many relationship. So taking an example, just recollect how we did it for the database involving shares and the nation. So nation was on the one side and shares was on the many side. So what we did was we added one column in the shares table with the name as nation ID, which was the foreign key, and that's how we established one-to-many relationship. Right here, it will not work. For here, whenever we have many-to-many relationship, we need to add an entity or a table. Okay, and this entity is called associative entity, and the purpose of this entity is to establish many-to-many relationship between the other two entities. Okay, all right, so now you might be wondering, like, why do we really need a third entity? Can't we do that without that? So answer to that is no. It's slightly more complicated. We need one table. We call that as associative table or an associative entity. So if you want to look at that practically, then this associative entity is something which exists in reality. Okay, so right here in our example, we have another data file which is called line items. So line items do exist. Okay, and what entries do we have in the line items? We'll just look at that, and it will make a lot of sense to us that this third entity which gets into the picture when we want to model many-to-many relationship usually corresponds to a real world entity. Okay, so here we have line items as our associative entity, and that really represents a real world entity. Okay, and what will happen for this associative entity? This associative entity is so important that it will have its own attributes, right? It has its own attributes, so it's better that we should make one associative entity. So now if we go back to the previous figure which shows the modeling of many-to-many relationship, then you can see that this many-to-many relationship is equivalent to a one-to-many relationship between items and line items, and also another one-to-many relationship from sales to line items. So many-to-many, we can think of an N-to-M, which is many-to-many relationship, as two one-to-many relationships. Okay, good. So now we should think about modeling, how to create a model that looks like this. And what I will do two modeling today. First, I will be doing the modeling using let's say discard here. Let me do the modeling using MS Access first, and then I'll do using MySQL Workbench. So here okay, so this is the data. I already created a database called many-to-many database, and for that I will have to create some tables. So let me start from there. So for creating a table, I should ask for external data source from file, I have Excel. I will browse and it should take me to desktop. I say 305543 data sets. Let's start with item. Open. Okay. Next. First row contains the column heading. I need to pick that. Now this is the time when MS Access is asking that should I add a primary key for you. I'll say fine, no problem. So that's where the ID got added to our table. I should call this items. Okay, yes, items is fine. I'll say finish. Close. We have items right here. Okay. So alright. So now let's create two other tables. Create table. I will get external data from new data sources. I'll do the same thing. Excel. And this should be faster. So let's take the sale table. Okay. First column is our, so first row has the name of the columns. Sale number. It's asking for ID. I will let it add that. I should call this sales. That's done. Close. So sales is right here. I will close the table one more time. So we have these two tables. These are the original two tables. I'll say entity involving items, the other entity involving sales. Now let's create the table for associative entity. So for that also I need to get the data from my folder. This is line item. Open. Okay. Next. Here it is important that we have a primary key from X. Otherwise this is a scenario where we do not have a single attribute natural primary key. Okay, so that is interesting. So we'll let MS Access add one field for us like ID, which we will use as the primary key for line items. We want to call it line items. Finish. Okay, so I should close this table and let me open line items. Good. So here is the line items. We'll look at line items later when we are doing a query. But right now we should be interested in creating a model like this. We need to create a model like this using MS Access. So this is little tricky, but we should get the basic things sorted out first. So let's go to item. Item has item number, ID, item name, type and color. ID is its primary key. Let's use ID as the primary key. You can use item number as well, but I will use ID. So what we should be doing here, this is the primary key. We will look for a foreign key in line items. So if you look at this thing, item number here, then this item number is actually coming from the primary key ID here. Alright, so what we should do, we should make sure that this field has the same data type as the ID field of the items. So for that thing I'll go to the design view, and the design view I will confirm that the ID field, which is the primary key of item, is long integer. So I should look at the data type of item number. So item number, this is what I'm concerned about. So by default this is double. I should change that and I should make that as long integer. Okay, then only this will work. Alright, so if you want to go back to datasheet view, it will ask you, do you want to change that? We'll say yes. Yes. Okay, so this field, which is item number, has been taken care of. Similarly, if you go to sales and look at the design view, you will find that the ID is long integer. So you need to take care of the sale ID as well, or the sale number right here in case of line items. So for line items, I'll go to the design view, and you have, so it's not line item, it's the, yeah, in the line items table, I need to fix the sale number, which is double here, just the way we had it for item number. I should change that to long integer. Okay, and now we are good. Okay, so now let's make that model, which is many-to-many relationship. So for that thing, we'll go to the database tools, and you know what I'll say, I would say that let's close these tables right here, because when you create the relationships, it often complains about that fact that you already have those tables open, and those are being accessed. Anyway, let's go to relationships, and here we will need all these three tables or entities. Let's add and close. So now the tricky thing about modeling many-to-many relationship is that first we will create one-to-many relationship. So for that thing, let's pick, let's do create new, and we need to pick the left table. I'll say items. Right table I'll pick as line items. You need to pick the ID, I mean a column, so I pick the ID field of items, and I should use item number. Item number is the foreign key in line items, so I'll say OK, and we will enforce referential integrity, and I'll say create. Okay, so one part of the relationship is done, which in fact is correct. Items to line items is one to many. Okay, now we should edit the relationship. For that, let's do this, edit relationships, and for that thing you'll say create new. I will pick the left table as sales and the right table as line items, and for sales I should pick the ID field, which is the primary key, and for the right table I'll pick the corresponding sale number, and then I'll say OK, and I will enforce the integrity and the referential integrity. Okay, so we got it, right? So this looks exactly like the way we have in our lecture. So items to line items, one to many, sales to line items, one to many. So do we have it? Yes, items to line items, one to many, sales to line items, one to many. So the trick right here in modeling using MS Excel is to first have one to many relationship between items and line items. If you're working on this example, you can do similarly for any other example that you're working on which involves many to many relationship. So first establish one to many between the entity and the associative entity, and then edit the relationship and add the other side of one to many relationship between the remaining entity and this associative entity. Okay, so let's go back to the lecture. Alright, okay, right, so what do we have here? Now again, this question about why a third entity, which I believe we have done already. So we were on this slide where it is telling us how to create many-to-many relationships. So as I showed you, first create one-to-many relationship, and then you'll have to use the edit relationship option. Alright, so these are some slides which will guide you through the process of editing one-to-many relationships. So that's what we had done. We first created one-to-many relationship between items and line items, and then we edited that again to add one-to-many part from sales to line items. Alright, so before that, let me give you another interesting thing, idea about another interesting thing, which is MySQL Workbench. In MySQL Workbench, it is very easy to model many-to-many relationships, so that's the reason I'm opening that up. And then you can go here, you need the password. After that, I will go to file, new model, and the new model I will use add diagrams. So here let me create a table. So I will use the example that I gave you in the lecture slide, the very first example, which is between students and the course. So for student, I should create the first field as ID, which is my primary key as well as not null. The second I will create as the name of the student, which is a variable character, and then I should say status of the student, and I can add, wait a second, a major of the student. And these data types are strings, so I'm fine with the default varchar 45. And if you want, you can add the address as well. Okay, so we created one table which is student with the attributes as ID, name, status, major, and address. Let's create one more table. This will be for courses, and for courses I'll have ID, which is primary key and not null. Let's create course name. I want to call that course name just to make sure that it's not confusing. You can create credits, and credits should be an integer type, and then you can have department, like which department is offering this course. Let's keep it simple. This should be fine. Alright, so we have these two tables, and we want to create a many-to-many relationship between these two. So what do we need to do? Let's pick this many-to-many icon from here and select these two. Okay, so see, interesting thing, we did not create the associative entity. Associative entity was added by Workbench itself, right? So this is a cool thing to have, right? So what happened, since we are modeling many-to-many relationship, and I was emphasizing from my lecture that for many-to-many relationship we need to have an associative entity or associative table. So if you do this modeling using Workbench, then what will happen, the very moment you pick this many-to-many symbol and try to connect these two tables which are involved in many-to-many relationship, automatically Workbench will add one associative entity. Okay, so now if you want to click this one, then you can see that once you click this one, you will find the foreign key primary key mapping. So student ID right here is a foreign key, and that corresponds to the ID field of the student. So this is highlighted. Okay, and when you pick the second relationship, you'll find the other mapping, which is between the course ID in the course table and the corresponding course ID foreign key that you have in the in this associative entity, which is being named as student has courses. So this is an automatic facility that Workbench provides. So that is one more reason why you should be doing a modeling with Workbench in comparison to MS Access. This is more flexible and has more features in it. Okay, so this is something I wanted to show you, and let me close it, and then we will go back to the lecture. Alright, so done the modeling, right? So we are done with the modeling. Let's think about the associative table. Like, what do we have in this associative table that we created? So here, pay attention to these two columns, right? We have a column right here which is sale ID, and then we have another column like item ID, and these two columns are in line items table. So what is the purpose of these two columns? So these two columns are in fact the foreign keys, right? So let me use my pen for that reason. Okay, foreign keys, we have two foreign keys here. Why two foreign keys? Because we are using each foreign key, like sale ID was used to connect line items to the sale table. whereas the item ID that we have is used to connect the item table with the line items. Okay, so this is an interesting fact. Since the line items, which is an associative entity that is in between the items and the sales entity in our modeling, so this table is involved in two relationships. Each of those are one to many. Therefore, we should have two foreign keys, and in both of the cases, if you remember, then this line item is towards the many part. So what does that mean? Go back, right? So here it's one to many. So line items is in many things. Similarly, one to many. So line items is in the many part of one to many. Therefore, we should have a foreign key here. Sorry about that. Okay. So sale ID is a foreign key, and similarly item ID is also a foreign key. Alright, good. So that explains this fact that sale ID is a foreign key and item ID is also a foreign key, and the corresponding table for sale ID is sales and for item ID is items. Alright, now if you pay attention to the fact that we said that as we made this statement that the question was, why should we have another entity called associative entity? Why should we have the third entity for many-to-many relationships? Then one of the point that was mentioned was that this associative entity that you will be having corresponds to some real life entity, and it will have its own attribute. So let's try to understand like what are the attributes which are unique to it. Contains the attributes which are unique, or the attributes that belongs to line item. So the quantity, alright, so the quantity is an attribute which makes more sense to line items. It will not make sense, it won't make much sense to have a column named quantity in items for sale. Similarly, keeping a quantity in sales table is not meaningful. In place of that, quantity is something which should be kept in line items. Similarly, the selling price should be in the line items. Okay, and these two are needed for the foreign keys. So this point that the associative entity may have its own attributes makes perfect sense in this example. Alright, so now we will move towards the query part. So let's see how do we write a query involving three tables. So I'll take you to the access. I should discard these things. Okay, so now what do? We go to home and we'll say create, and we want to write some queries. So let's start with the simplest query first. I will write a simple query because that's how, these are the steps that we need to follow if we have to write a SQL query in the MS Access. So this is my item query. I will go to its SQL view, right? So let me start writing simplest possible query, and here it is select star from items. No surprise, you should see everything from items. Just to make life easier, I will open all the tables so that I can easily reference all these tables for my query writing. Now I'm back to my query. Go to SQL. So I was only selecting from one table, which is items. So let's try combining the information from all the different tables I have. Sales and line items. So what I'm doing, I'm just doing a Cartesian product of items from the elements or the tuples from items, tuples from sales, tuples from line items. So let's see what will happen. Okay, so a lot of records, right? Most of these records are useless, right? Because it's just a concatenation which makes no sense to us. So what we should have done instead was, we should be little, sensible, and we should do join, right? So how should we do join? Let's do implicit join first, and let's only combine those tuples across these three tables, which map in foreign key primary key values. So what do you mean? I mean something like that. Items dot id equals line items dot item number, and sales dot id equals line items dot sale number. Alright, let's run this thing. Good. So you can see that now it is making a lot of sense, because this item id, right, is being mapped to line items dot, wait a second, yeah, this 2 matches to this column is matching this column, right? So this is good, this is making sense, because we are concatenating those two tuples from the item table and the line items table, where those item IDs match. Similarly, if you look at the sales ID here, which you are getting from sales, and if you compare that with sales dot sale number, no, this is not the one, line items dot sale, right? So this, if I extend that, yeah, so the sale number, right? Sales dot id should have the value corresponding to the sales number. So these two values, these two fields are matching, right? So it makes perfect sense. Now why? Because we are doing join, and join is something which we should be doing. So let's be specific. Let's not list everything. In place of that, we should list what? Item name and sale date. For sale date, we have date, I think. Item number, sale date, and quantity. Let me see, what field do I have for quantity? Linqty, this field. Okay, qty, line line quantity. Alright, and you can have the price as well. Line price, lineprice. Price. Okay, good. So let's run this query. Okay, now this looks a lot better. We have 4 attributes, which are item name, date, quantity, and line price. And the item name you are getting from the item table, date you are getting from sale table. Okay, so date we have in the sales table, and then quantity you are getting from line items, and the line price also you're getting from line items. Alright, good. So let's move on. So this is what I kind of wrote, a very similar query. Now the next would be little complicated. This is little complicated because we have explicit join, and explicit join, as I said, is recommended when you are working with the multiple join operation, because then debugging gets a lot easier. Whereas in case of simple implicit join, you might get into trouble. Okay, so what I should be doing, let me write the same thing, but the only thing right here is sale number. We are sorting it by sale number. So let me go and change this thing. Do I have sale number? No, I don't have sale number. Then let me also have sale number. Sale number. Yes, I do have sale number, so I'll go here and should run this thing. Okay, so here I should say sales.sale. Sales dot sale number. Okay, yeah, good. So we have sale number also. Okay, so what do we need to do here is maybe order by sales dot sale number. Okay, yeah. So the only thing that I'm changing right here is this join condition. So join that I'm using right here is the implicit join. So if I have to do the explicit join, then how should I change? So this is where I will change. Okay, these are the places where I should be changing this query to make this query using explicit join. Okay, so let's go. What should I do here? I should say select item name data. I'm not changing anything. Sorry, select item name, date, line quantity, prior line price, sales number from items inner join. Inner join what? Yeah, this is interesting. So I'll explain to you why I'm doing it. Inner join sales right here. Line items inner join sales on let me delete these things to make the how do we inner join how do we inner join line items on sales? So it should be line items dot sales number is equal to sales dot id. So what will happen? We'll have one inner join between line items and sales, which will result in a table obtained as the join operation between line items and sales. Now this intermediate table that you are getting as a product of the inner join between the line items and the sales would be used to have a inner join with items. Okay, so here you will say on items dot id equals line items dot item number. I think we are good. Alright, this should work. Good, it worked, right? So it worked. The only thing is that you need to practice a little bit and you need to reason about it. So one more time, let me explain that. So what is happening in this case? First we are doing the join between inner join between the line items table and sales table. And when you do the join of line items table and the sale table, then the resultant would be a table with the number of columns equals the number of columns in sales plus the number of columns in line items. So once you get this intermediate result of the inner join between sales and line items, we will use the inner join between the items table and this resultant table, and the condition is same, which is items.id is equal to line items.item number. Alright, and you get the required result. So back to the lecture slide. So again, as I do, I will encourage you to try out all these examples because these are simple. but it needs practice, right? If you feel that you will be able to do it without practicing, just reading the lecture slides, probably that will not work. Okay, so it's kind of programming which you need to practice. All right, so same thing is happening in this case also. You want the sale number, you want sale date, item name, item type, quantity, price. You need more information than what I needed from sales inner join. So here the order is different, right? So I had from items inner join the remaining two, but you can do it that way also. You can change this order as well. So here it's a different ordering, right? So interestingly, this will work too, because same thing. You're saying from sales inner join, items inner join, line items on items.id is equal to lines item.id. That's how you will be joining items and line items on the primary key, foreign key, a pair of attributes. Then once you have this result obtained, then you will do the inner join between sales and the resultant table. Condition is same, which is sales.id is equal to line items.sale.id. Yeah, keep in mind that this sale id attribute name is not there in the data which I shared. So if you want, you'll have to change the name of your attribute to what we have in the lecture slide if you want to try the same queries. Otherwise, it's very simple. You'll just replace sale.id by sale number. Okay, so what else do we have here? Let's see another query. So list the dates, names of item, quantity, and value of item. Right. So how do we do it? Let's look at this query itself. Okay, which should be easier to understand. We need the date. So sale date is a column in sales table. So you need to have sale date, item name. Item name will come from item table. Quantity will come from from line items. Price will come from line items. Now you need to find out the value of the item. So how do we get the value of the item? Well, you'll have to multiply the quantity and the price, right? So it seems like some item is bought, we need to find out how much the sale was for a particular item in a particular sale. So if somebody bought an item, say A, 10 pieces of that item, then its value will be 10 multiplied by the price. Okay, so for this value of the items, you need to consider the quantity and the price. And the quantity as well as the price you are getting from the line items table. And you can call that as total. And we want this information from these three tables: sales, line items, and items. Now you have the join condition, and here we are doing implicit join. And implicit join is simple compared to explicit join, because the syntax is little complex compared to implicit join. In implicit join, you just need to establish this equality, which is line items.sale.id is equal to sales.id. And there are two conditions, right? Because we are connecting these three tables using two conditions. One condition which will equate the sales ID, which is the foreign key, with the ID field of sales. And similarly, item ID, which is the foreign key in line items, to the ID field of items. Okay, and it should work perfectly fine, and you'll get the result which you see right here. Alright, good. Let's move on. Now this is an interesting query actually. This query is interesting for the reason that when you have a query that involves the comparison of the dates, so I should use a pen right here. So here the query involves the usage of date. So list the names of item, quantity, and value of items sold on January 16th, 2003. Now whenever you are comparing the dates, then for that you will have to use hash signs. Alright, so if you were thinking that you will have you will use sale date is equal to, you want to use this date as a string. If that was your thought, then that is unfortunately wrong. Okay, so this will not work. The double quotations won't work with the date. In place of double quotation, you should be using hash sign. So for date comparison, use hashtag. Okay, so what did we do here? Well, we have to do the join, right? So everything remains the same as we had in the previous slide. Okay, so everything is same here. The only thing that we are adding right here is that we want this information only for, okay, we don't have complete result. So here we are interested in only having the information about the sale that happened on January of 16, 2003. Okay, so that means you need to add one more condition here. Okay, so this is the filtration condition, which means the simple where clause. Whereas the other two conditions that you have here, these are the join conditions. Right, so in the where clause, if you look at, we have one condition, two conditions, three conditions. So the first two conditions that we have, which is similar to the previous query, is for joining these three tables. And the last condition that you have, which you see here, is for the filtration. Okay, yeah, and the important message is how to use the date for comparison in SQL query. So the date value goes in between the hash symbols. The date literal syntax, okay, the date literal syntax is different from text. Text means string, so you cannot use double quotations. So please keep that in mind. Alright, so now this is an exercise for you, and for this exercise what you should be doing, you need to make the tables as I did in the beginning of the lecture, and you will be creating these three tables from the three files that I shared, and make sure that you are changing the data type of the foreign key in the line items to the long integer, which is usually the type of the primary key. Okay, so then you need to write some query. So we have to write a query that computes the total value of the sales of each item by date and sort by the date. Okay, and here we should also include, we need to include a count of the items sold on each date. Alright, so let's see how we'll do that. So this is an exercise for you people to do, so I'll recommend you to pause and do it, and if you have any problem, then you can watch the remaining of my lecture. Alright, so let me go back to the access. We need to write a query to compute the total value of sale of each item by date, and we should have the count as well. So what do we do? Let's modify this query right here that we have. Anyway, we are doing the join, so I will not mess up with the join. I will, what do I need? The total value of the sale. Alright, so what I should do, it seems that I need to do a group by. So how do we group by? Group by, you need to group by the item and date, it is saying, right? We need the value of the sales of each item by the date. So we need to group by item number as well as the date. Okay, then it will make sense. So I should change here, I should change something here. I should say group by item number and date, right? And the item number that you're getting here is coming from the line items table, and I should do, let me go back, we need item name, sale date, So see, sometimes the query also gives you some idea. The query result also gives you an idea. You need item name, you need sale date and number of items sold and total sale. So I should have item name. Let me go back. I already have item name. Then you need date. I already have a date, right? So these two things I need, item name and date. I'm using that in my group by as well. And then what else is needed? Then you need to compute the total value of the sale of each item, and you also need the count. So I need some, let me do count star as, so it should be number sold, and I need sum of the price, line price, right? So they are saying that we need to sum it up. We need to find out the sale of each item, right? So the sale of each item we need to find out, and this is to be grouped by each. It has to be done item wise and date wise, so that means we have to group by item and date. Just doing item now, item wise would be different, and here I should be consistent and use item name, otherwise I'll have difficulty. Alright, and then there's one more issue. They are saying that primary sort by date, order by date. Alright, let me see. The rest I'm not changing because this is the join that you have to do. Okay, so I believe we are fine. I should change this one too, on this attribute which says total sale as total sale. Alright, and let's run that. Okay, so I believe this is what we have in the result. Yes, total sales. Okay, good. So that was not difficult. The only difficult part that I believe which we have in this query is to figure out that, just to figure out this fact that we have to do what? This total that you're computing, compute the total, right, is based on sale of each item by date. So you have to have the item field as well as the date field. Take these two together and do a group by. So this is an interesting case where we are using group by using these two fields. And you should have the item name. Item name is something you're getting from item table, and then you can have the sales date which is coming from sale. The rest of that was simple. So yeah, we do have the corresponding SQL query for you to check back if you are stuck. Alright, but an interesting example to try. Alright, so now let's look at a few other interesting select clause. So we have exist. Exist is an interesting clause. So as I said, probably that the relational databases are popular because popular and are so successful because they have the mathematical foundation, and that mathematical foundation has to do with sets, right? So this relational thing is coming from sets and mathematics. So if you remember from your basic mathematics, we have some operator like this. This is called existential operator. Okay, so this checks whether we have anything that exists and that satisfies this condition or not, right? So as an example, if I say that we have a student Sam, and Sam has the grades like A, B, B, C, B. Okay, so the grades of Sam are A, 3 B's and a C. So these are 1, 2, 3, 4, 5. What the letter grades for 5 subjects. Now I can ask this thing, I can ask this question, do we have a case, does there exist any A in Sam's grade? Right, so this will evaluate to true or false depending on what we have here. So if I'm asking, does there exist any A, then the answer to that should be true. Why? We have one grade, that is A for Sam. And if I change that statement slightly, and if I say that, fine, A is there, right? So I can also ask, this is set based operations, okay, existential operation, this E, flipped E. If I say, does there exist any grade D in Sam's grades? So you look for D, and you should check, like, do we have any any grade that equals D? So the answer to that is false, right? Because D does not exist. So any one instance of D will make my statement true. So it is false because there is no D. So exists is a clause which helps us in writing a SQL query which involves the computation of this kind of expression. Okay, so let's see. Let me take you to the example, and then it will make more sense. I just wanted to give you some idea about where exactly this exists came from. So the answer to that is, it's coming from this existential operator, which you might have seen in your mathematics lectures on sets. Existential quantifier, this is called existential quantifier, this operator. Alright, so now let's look at the cases, like when we will need it. So what will happen, it will either return in true or false. We have seen that operator on simple example of the grade. When will that return in true, and when will that return in false? Now you may write a number of interesting queries based on this exists clause. So let's see an example. Now when you use exists in your SQL query, then this will return in true if the table contains at least one row. Okay, so when you're using exists in a query, then it will return true if the table contains at least one row satisfying the condition. So let's look at this query that we are writing. So query is required to return, let's look at this, report all the clothing items type C for which sale is recorded, right? So we got a hint that the type C that you have for item represents clothing, right? So item type is equal to C means a clothing item. Now what is the requirement? Requirement is that we need those items for which have been sold. Sold means they should be part of some sale. All right, and whether an item has been sold or not, that information we can get from the line items table. So see, how can we solve this query using exists? So for that thing, let me walk you through this SQL query. I believe that would help. We need item name, item color. This you'll get from items, okay, where item type is equal to C. So if you just try this thing, if you only write this query, then from this query you will get all the item name and item color that belongs to the clothing type. So you'll get all the clothing items because it's very simple. And this whole information you will get from items itself. Alright, but our requirement is slightly different. The query that we have to write is more complex. Why? Because we want only those items to be listed that have been sold. Right? And how do you find out whether the element has been sold or not? Let's put another condition. Okay, so what is the condition that we have here? So what we can do here is that this is query number 1. Let's look at the query number 2, and then we'll discuss about the combination of these two. Now my question to you would be, if I run this query number 2, will I get any reasonable answer? Is this complete in itself? The query in the top is complete in itself, I'm sure about it. If you run that, you'll get the clothing items from the items table. In the second query that you have, you are selecting star from line items, where line items is equal to item ID and item where line items dot item ID is equal to items dot ID. So here you are making a join. You are making a join between, this is join. You are joining. What are you joining? You are joining items and line items. And if you do this join of items and line items, then what the result that you'll be getting would correspond to all the items which have been sold. Alright, so an item will only figure in the line items if that item has been sold. If the item is not sold, then this item will not come in the line items, right? So this whole thing that you have right here will only return those line items where this will only list those items which have been sold. Now when you combine these two queries, then what is happening here, this and thing that you have is connecting your where clause, right? So this where clause had just one condition before. This where clause has just one condition in query 1. Now when you put an and use an exists and attach the query number 2 to the first query, then what is happening? The result is that we are getting the information about items, which is item name, item color, only for those items which are of type clothings and which figure in the item list, right? What does it mean to be figured in the item list? That means they have been sold. Now how do you ensure that this item has been sold? Because you're using exists, right? So only if you have more than if you have one or more entries in this subquery, the exists will return in true. Otherwise, if nothing figures out here, that means that item was not sold. I mean, nothing was there. All right. So this is a very interesting way of using exists to write the queries like this. All right. So please do this exercise, and this will be fun. If you want the explanation, we have right here. The subquery is evaluated for each row of items. Resulting row is only added to the result table if exists evaluates to true, right? The same thing which I am trying to explain you. So exists is very handy in these kind of situation, these kind of queries. It makes your life a lot easier. Okay, so when we are thinking about exists, we can also think of another clause which is not exists, and not exists will do the reverse of that. So if you want to report those items that were not sold, right? So either you'll be interested in finding out the items which are popular, clothing items which are being sold, then you can use exists the way we have used in the slide right here. And you can also ask a counter query which says that list those clothing items which were not sold, right? Maybe they are not popular. So for that, the only change that you have to do in this query is replace exists with not exists. Okay, so that's the only thing we have changed here. Just added not. Alright, and you have the same query, but you'll get the opposite result. White color, okay, so the red color item was sold, white color item was not sold. Okay, good, interesting. Now the other query that we have is a little more interesting. It is interesting for the reason that in the set theory, we have an operation called divide between two sets. So why we are discussing divide? Because we have already seen the existential quantifier. This is existential quantifier. Let me write that here. We will look at universal quantifier. The symbol is this thing. We have already seen the existential quantifier which was this symbol, right? And for that thing we have exists as a clause. But now we are interested in using an operator which can solve a problem which will boil down to universal qualifying. Alright, so as an example, my example was for Sam, who has got grades like A, B, C and all. Now if Sam got B's, right, all the B's, then I will ask the question, does Sam get all the B's? That means, are all the grades that Sam obtained B? Then the answer to that would be true. Sometimes we may be interested in doing a query like this. Did Sam get all the B's? So for that you will be writing for all. For all grades, did Sam got all the grades as B? Right? All for all grades is equal to B. Okay? So this is also important in certain scenarios. We will have an example and we'll try to see. Now the unfortunate news is that for there exists a thing of an existential quantifier. We do have a clause like as exists, but for this universal quantifier we do not have any direct clause. So we need to think about alternate ways of solving it. So it's not directly mapped into SQL, right? So the interesting thing is that how do we solve that? So we solve this problem of a universal quantifying by using not exist. Okay, so this is a little difficult for the student to grasp initially, but if you reason about it, if you reframe your problem in a different way, then it can solve the problem. So let's take an example and try to solve that out. So example of a query is that we need to find all items that have appeared in all sales. Okay, so you need to find out. So it's not as simple as the previous one. In the previous query where we were doing exist, we needed to find out the clothing items which figured in some sale, right? We were interested in finding out the items, clothing items which were sold. That means they need to figure in just one sale, and that will establish that they were sold in some sale. But now we are more ambitious here. We are saying that find out all the items that have appeared in all the sales, right? So the requirement on that item is that it should figure in every sale. So how do we solve that out? Well, we have this thing, we will use not exist, but understanding the uses of not exist for this query is difficult unless you understand how you will rephrase this query. So this query that we have, which says that find all the items that have appeared in all the sales, we will write it equivalently as this way. What is it? There does not exist any sale, no sale, where item did not appear. Okay, so we are looking for a sale, right? So we need to find out the sale. We need to find out an item which is such that the item appeared in every sale. That means there did not exist any sale in which this item did not appear, right? So that's the approach to kind of translate your query to an equivalent query and then write that query using not exist. So find an item, right? So the same thing that I'm trying to write here, we have it here. We need to find items such that there does not exist a sale in which that item did not appear, right? So it will involve couple of not exist, because no sale is a not exist thing here. The item did not appear is another not thing. So we will have couple of not exist that we will be using. So let's look at the example. Okay, so like how can we solve this problem using not exist? So what do we need? We need item number, item name from items where not exists. So this is a little tricky actually. So what we are saying that let's find out the item, an item name from items where we do not have any instant that this item did not appear in any sale. Okay, so for that thing we'll have select item number, item name from items where not exist, select star from sales where not exist, select star from line items, and then here we have the join condition. All right, so well, I have the, as goes my experience in the past, I found that the student did not had difficulty understanding these things. So don't worry if you did not did not understand it completely, but I'll encourage you to kind of develop this insight, because then you'll get to know that why is this divide query so complicated. For the reason that we do not have a clause like exists. The only way we can do is by using couple of not exists. And why should we use couple of not exists? Because that's how you will translate your query, right? That's how you will translate your query into something like this, that we will find the item such that there does not exist a sale in which this item did not appear. Alright, so for that we are saying select item number, item name from items where not exist. Then the parenthesis we have, this parenthesis is ending right here, starting here, ending right here. Okay, select star from sales where not exist, select star from line item where line items dot item id is equal to item dot id and line items dot sale id is equal to sales dot id. Alright, so now it is also possible to write the same query in a different way. So how will you write this query in a different way? For that thing, what we will be doing, we will write this query involving a having clause. Alright, so what do you do? Select item id, item name from item line items where items.id is equal to line items.id. So what you did, you joined item table and line items. Line items. Why did you join these two? Because I want to find out the information about the item which I'll get in the item, like item ID and item name, and I want to find out whether this item appeared in every sale or not, and whether the item appeared in a sale or not, that information you'll get from the line items table. So let's join these two. After joining, we need to find out whether this item appeared in all sales or not. So how to do that? Well, let's do group by. Alright, so you can do group by. And why are you doing group by? That is interesting actually, because once you group by the item, then you will find out how many times this item was sold. Right, and finding out the information like how many times this item was sold, and also finding out how many sales we have, we can use that to filter out the item which was sold in all the sales. Right, so how do we do that? Do a group by on item ID and item name and having, right? So we'll have to apply having clause, because once you have grouped, now you want only that item which was sold in all the sales. So how do we do that? Let's count the number of sales that we have in the line items. And this is something you're doing only after doing the group by. That means you are counting how many times the item has appeared in the sale record. Then this should be equal to the number of sales that you have. Right? How do we find out the number of sales? For that you need to look at only the sales table, and from the sales table find out how many sales have happened. Alright, so this is an equivalent way of writing a query for divide operation, which is for the universal quantifier. Alright, so now we have a few more operations like the union operation, which is equivalent to doing the union of two sets. So sometimes it gets very easy to solve a query if you approach that query from union point of view. So let's take an example for that. Now if the requirement is that we have to list all the items which were sold on January, all the items that were sold on January 16, 2013. So it is very easy to write one query. Let's call that query 1. In the query 1, you will find out the items that were sold on January 16, 2003, which I believe is simple. You'll have to join these three tables, right? You would wonder why three tables. Okay, first of all, you need to find items name, item name. This item name is coming from item table. Whether they were sold or not, that information will come from line items, right? This is where you have the information that the item was sold or not. The entry in the line items is only for those items which were sold. And why do you need sales? Well, you need sales because you need to find out the date when that was sold. Alright, so we need all these three tables. So see, we need items, line items, and sales. And the rest is simple. You need to do the join of these three tables involving two conditions, condition 1, condition 2, and then you need to filter out. How do you filter out? You need only this information for the sale date, which is January 16, 2003. So this part is your query 1. This is your query 1. Okay. Now there's another part. The query says that either the item should have this requirement or the item should be brown in color. Now this query 2 is very simple. You need just one table, which is the item table. So how do you write query 2? Write query 2 this way, which says select item name from item where item color is equal to brown. Good. So we know how to write query 1, we know how to write query 2. Then the final query that we have is simply the union of these two, right? So how do we do union? Use this keyword union. Alright, so using query 1 union query 2, you will get the final query. Q is equal to Q1 union Q2. Okay, yeah, so please try this query. I did try and it was fun. Alright, the trick is that you should be smart enough to figure out that this query can be easily solved using the union. Otherwise, it might be a little difficult. Now, similarly, you can think of intersect operation also. If you have to write a query which should satisfy both the requirements, then you will do a select operation. So previous thing needs to be changed. In the previous query, we had the condition of OR, and here the condition is an AND. So list all items that were sold on January 16, 2003 and are also brown. So if we are lucky, if there's something like intersect, we will simply use intersect for query Q1 and Q2. But there is a bad news. The bad news is that intersect is not supported by some DBMS. Okay, so intersect is not there in MS Access. So if you want to try it out, you might fail. But there is this notion that someone can implement intersect as well. So you might find some SQL system that has intersect. Okay, so now we have are we on track exercise, which I'll leave on you. So please do this one. So you have to report all items of type F that have been sold. Okay, so please do this exercise, which I believe is very simple. You should have the understanding of axis, right? And axis is something we discussed in this lecture. Select item name, item type from items, where item type has to be F and it should be sold, right? And we did similar query which involves checking the condition whether the item was sold or not. For that you'll have to do the join between the items and line items and figure out that do we have any record in this join or not. Okay, so that was it. Actually, that was the purpose of this lecture, to give you some idea about many-to-many relationships between two entities and create a database and then write queries. And we did learn about some clause, like we learned about exists, we learned about not exists. Okay, and we also learned about how to deal with the date fields in equality. You need to have the hash sign before the date value. Alright, so that's it. Bye bye, take care, and please do these exercises. I'll see you in the next video lecture.